Salam and welcome everyone. So today we're going to be working on the question on the screen that says standard enthalpy of the reactions changing HR of graphite powder with hydrogen and chlorine gas at 298 Kelvin are given below. So we've been given three different equations below. The first one is carbon graphite reacting with hydrogen gas. The second one is chlorine gas reacting with hydrogen gas. And the third one is chlorine gas and graphite solid or carbon graphite reacting with hydrogen gas. So each one of these equations has the enthalpy of reaction values to the right of each one of the equation. So that's the first part, which is just simply the data. Now I wanted to say this before I start the question part of the question part of this whole question is that this is a question from one of my students who had like past exam packets, so we're just working on it together, and I just thought it'd be useful for the other people on my YouTube channel. So anyways, the next thing the question asks is to calculate the change in enthalpy for the reaction below. And when you look at this reaction that is below and compare it to equation 1, 2, and 3, you'd see that you have like similarities. You have CH4, you have CH4, you have HCl to HCl, you have to HCl, you have um this I forgot to put the CH2. So you have this CH2Cl2 and CH2Cl2. You also have H2, you also have a bunch of H2s here. One thing you need to know when you have a question like this is that you're going to be dealing with Hess's law. Hess's law tends to ask you to for the change in enthalpy for a particular reaction. Generally, Hess's law just simply states that the change in enthalpy or the total change in enthalpy of a reaction is equivalent to the sum of the enthalpy change for each step of the reaction or each individual reaction step. So basically, the change in enthalpy for this reaction is going to be the sum of all the different reaction 1, 2, and 3 steps in all of this whole reaction that is going on. So that's just basically what it's teaching us. And we're going to apply Hess's law, understanding, and of course, some math for us to be able to solve this question. So I just wanted everyone to be on the same page. So we're told to calculate the change in Hess enthalpy for the reaction below, which is just CH4 plus 2HCl will give you CH2 Cl2 plus 2H2 gas. So the first thing you have to do when you have a question like this is for you to focus on the general equation that you're given or the main reaction that we're asked to solve for. And to do that, so we're going to start with solution. To do that, we are going to simply focus on each major molecule. So the major molecules are the molecules that don't come more than once in the reaction. So the major molecule, um just step by step. So let me explain it right. So we're going to be focusing on the first molecule that we have. The first molecule that we have in this general equation or the equation, the major equation that we're working with is CH4. So we're going to write CH4 here, okay? And we're going to compare this general equation at the bottom with the individual equations 1, 2, and 3 at the top and compare where we have CH4. So looking at the first um, reaction 1 or equation 1, we see that we have CH4. So basically we have successfully had have where CH4 is. Now we're going to be thinking when we compare equation 1 to the general equation at the bottom, you see that equation 1 is on the product side and then the general equation CH4 is on the reactant side. So what we're going to do is that we are going to, this is how you do Hess's law, by the way, we're going to switch equation 1 sides. And what that means is that we're going to take the product side to the reactant side and the reactant side to the product side. So we're going to rewrite equation 1 in such a way that CH4 is the reactant and everything else is on the product side. So equation 1 now becomes CH4 so that it matches, by the way, the general equation at the bottom. That's how you solve equations like this. So you have CH4 gas, okay, that would be Cs plus 2H2 gas. So when you do that, you have, of course, you're going to flip equation 1. And when you flip it, you go from negative 74.8 kilojoule per mole to positive 74.8 kilojoule per mole. So you have positive 74.8 kilojoule per mole. So that's that one. Then you have 2HCl gas. So you have 2HCl gas, and that's the second thing because we have successfully worked with this one. Now we're focusing on this one, 2HCl. So you have 2HCl compared to what we have. We see that for equation 2 and equation 3, we have 2HCl in equation 2 right here. Okay, right here. We have equation 2 right here. Now, one thing you have to remember is this: you have equation 2 on the product side in for reaction 2, and then the general equation that we're solving for, we have it on the reactant side. So we have to flip just like we did for equation 1. So that's just basically going to be the next step. So for CHL, we're going to switch equation 2 sides, right? So it's just a simple repetition of what we did. And when you switch sides, you're going to end up with 2HCl gas. So you end up with 2HCl gas will give you Cl2 gas plus H2 gas. And of course, when you flip, you're going to have a change in HR value. Now, I wanted to mention that because of this, you're flipping and you're taking product to reactant, reactant to product, naturally the enthalpy change value, enthalpy of reaction value is going to change. So it's just like going from an exothermic reaction to an endothermic reaction. One, from an exo to an endo. So when you go from negative to positive, you're going from an exo to an endo. So this is basically makes sense, honestly, because this is how it's supposed to be done, right? This is literally how it's supposed to be done. When you flip the side or go from reactant to product, know that you're going to go change the value from the negative to a positive. And if it's from a positive, then you go from a positive to a negative. So that's how it's done. So now in this case, now we can see for equation 2, we have negative 184.6 kilojoule per mole. It becomes what? It becomes positive 184.6 kilojoule per mole. So that's basically the answer to this one. Now, before we go ahead, I want to make sure that you guys are following. So for equation 1, this is the new equation that we're going to work with. Okay. Anytime I say equation 1 now, note that it is what we've flipped and what we've worked on. And equation 2, it is what we flipped and what we've worked on. It's basically what is at the bottom. This part, first part that is given to us in the question, is just data that we're supposed to work with to get the general to get the change in enthalpy for the reaction. So that is just, we're using this 1, 2, 3 up here as data, while the 1, 2, 3 at the bottom is actually the solution to the question. So yeah, just please pay attention. So that's it. Now we're going to look at the third one that we're given, because we have done this one and this one. Now we're looking at the third major molecule in the reaction. You have CH2Cl2. So you have CH2Cl2. Now, CH2Cl2, when you compare the the major equation at the bottom plus equation 3, we'll see that there's literally nothing that changes. There is no there is no like difference in what we have. There is no like different we don't have like a different flip, we don't have a different switch, we don't have maybe two molecules here and five molecules there, or one molecule there, two molecule there. We just have it as it is. So for equation 3, which is just simply CH2 Cl2 gas, we're going to leave equation 3 as it is. So that is it. Leave equation 2 as it is. So leaving equation 2 as it is, leaving equation 3 as it is. Sorry, because that we're working on. So we're just going to have chlorine gas plus H2 gas plus carbon solid. We're just going to rewrite all of that. So what you end up with is just this. So you have chlorine gas plus H2 gas plus a CS solid will give you CH2Cl2 gas. So what you end up with is negative 124.3 kilojoule per mole. So that's it. That is literally the answer. So that is it. So when you leave all of this as it is, you're going to be like half done, right? Because you're reforming the new equations that you're going to use to solve the question that you're being asked. Now, before we go ahead, you're going to be wondering, well, we have 2H2 here. How come we just worked on these three? Well, anytime you're done with one part of the equation, for example, since we've used CH4 for equation 1, HCl for equation 2, and CH2Cl2 2 for equation 3. And by the way, it doesn't follow that way. Sometimes CH4 could be there and we're going to work with equation 2 or equation 3 to solve it. So this one just happened to go in order: equation 1, equation 2, equation 3. Anyways, so when you have worked with three different equations that we have, you can't work on anything. That's one. Two, H2 that we have here is literally in each one of this equation. So whenever you have multiple molecules, right? Whenever you have when you have a molecule that is in multiple steps, just know that eventually that molecule is going to have is going to cancel out in some instances, or sometimes cancel out in all instances, right? For example, a common or a minor molecule in this particular situation is carbon, because we have carbon in reaction 1, we have carbon in reaction 3. You have hydrogen. Hydrogen is in reaction 1, reaction 2, reaction 3. Chlorine is in reaction 2 and reaction 3. So what are you going to work with any of this to solve this? But if you look at methane, CH4, hydrochloric acid, HCl, and then CH2Cl2. If you look at these three, you're going to just simply know that they do not appear in any of the reactions in any other reaction except maybe for one. So that's basically what I'm saying. So CH4 only appears in reaction 1, HCl only appears in reaction 2, and of course CH2Cl2 only appears in reaction 3. So now we can simply ignore this and not work on it. It's just going to cancel out when we're working on the Hess's, while we're working on the Hess's law. So next thing you have to is add all three equations. So to do that, we're going to arrange equation 1, equation 2, and equation 3. So for equation 1, so you have CH4 gas, Cs plus 2H2 gas. So you have positive 74.8 kilojoule per mole. That's number 2. 2HCl gas. You have Cl2 gas plus H2 gas would give you positive 184.6 kilojoule per mole. And number 3, you have Cl2 gas plus H2 gas plus C solid, and you have CH2 Cl2 gas. So you have positive 124.3 kilojoule per mole. So that's basically it. Now, of course, since this is basically what we have, you can now go on to solve it. Now, this is just all us applying the knowledge of Hess's law to solve this eventual question, which is to find the enthalpy change of general equation. So please pay attention. Now, we're going to cancel out anything that appears on the product side and on the reactant side in all these three reactions, right? In any of the three reactions. For example, if you have X here, so you're doing algebra and you have X here and you have X here, it's the same thing as x is equal to is the same thing as x minus x equals to 0, because when you take this one to the side, it will be x minus x. So when you have x equal to x, without even saying moving it over, you already know you're going to cancel out to equal 0. So that is the same knowledge of algebra you're going to apply here. Like, you basically will treat them as variables when they appear like similarly. For example, you have Cl2 in the product side of equation 2 and Cl2 in the reactant side for equation 3. You cancel that out. You have carbon solid in the product side of equation 1 and carbon solid in the reactant side of equation 3. That cancel out. Then you have the H2 gas in on the product side of equation 2 and the reactant side of equation 3. So now you have successfully canceled out everything that needs to be canceled out, and you're left with CH4 HCl on the reactant side, and you're left with 2H2 and CH2Cl2 on the product side. So this is how you solve it. So we're just going to rewrite the equation to have CH4 gas plus 2HCl gas on the reactant side to give you 2H2 gas plus CH2Cl2 gas on the reactant side. Now, this new equation that we've gotten from solving it must match the general equation that we're given in order for us to move on. So we have CH4 and 2HCl on the reactant side. So let's see if that matches. Okay, we have CH4 and 2HCl on the reactant. Perfect. Then we have CH2Cl2 on gas on the right side and 2H2 on the right side. So we have 2H2 on the right. Oh, perfect. So when we do that, all we have to do is just add up our all we have to do is just simply add up our values, like our enthalpy of reaction values. So now the change in HR for the general reaction that we're given at the bottom would just be positive 74.8 kilojoule per mole plus 184.6 kilojoule per mole plus 124.3 kilojoule per mole. Now, I just realized from my notes that I made a mistake, which is very good for people to like review their work. Looking at equation 3, it's not positive 124.3, it's actually negative. So it's going to be positive negative, right? So let me just be positive negative will just be negative. So minus here. That's my bad. Thank God I quickly saw it to correct it. Anyways, so you have 74.8 plus 184.6 minus 124.3. So when you put all of this formation on your calculator, you end up getting positive 135.10 kilojoule per mole. So this is basically the answer to the question that you're asked. The answer to the question you're asked, which is calculate change in enthalpy for the reaction below. The reaction below the change in enthalpy is 135.10 kilojoule per mole. If you have any questions, suggestions, concerns, please put it in the comment section of my YouTube channel. I help students succeed in all their STEM related courses, whether they're in middle school, high school, or college. And I am an amazing tutor, and a lot of students who have tutored with me have amazing experiences. So email me at shuhabitutoring@gmail.com to book a session. I welcome all of you. And yeah, I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.